Ladies and gentlemen, welcome back, finally, to the workshop. I think it's been about 2 years since I posted my last video. It has been a long time. I haven't done much work in the workshop in a very long time. Because of that, it was an absolute mess in here. I probably spent, 8 or 9 hours cleaning it up just so that I could find my workbench again. And as you can see, it's nice and clean. So very good to be back here again. Good to be doing another video for you. And this one is going to be a little bit different. Where we left off last time, the last video that I posted, I was working on that $75 Dumble build that was modifying the PV Valve King to be a Dumble type circuit. And I will get back to that. The reason that I stopped working on that was because I had an issue. Maybe a bad connection, maybe a short somewhere, I don't know what it is yet, but basically it was very noisy and the signal was very weak, and so I really needed an oscilloscope to find out where the issue is. And the scope that I had was in very poor condition. Well, the screen was in very poor condition. Just the CRT was so dim you could barely read anything on there. And I had planned on fixing that, but it just didn't make sense financially to do any work on that scope, so I gave up on that. And I ended up buying one of these. This is a Handtech 2D42 handheld oscilloscope. Really cool. And it's actually got a built-in signal generator as well, which will be very handy for working on guitar amplifiers. So now that I've got this, I can get back to working on that PV Dumble conversion thingy, the $75 Dumble build that I had been working on. So I don't know exactly when I'll be able to get back to that, but hopefully very soon. But for today, I've got a friend's amplifier that he wanted me to fix. Now normally I don't do amp service. It's just not really my thing. I'd rather stay on the creative and the design side of things. But today I've got this vintage, this is an early Silverface Bassman. I don't remember what year he said it was. The Fender historians would probably know. It's a AB165. So real early Silverface, mostly a blackface circuit. This amp is in very good shape. I mean, very clean. One of the cleanest vintage amps I've ever seen inside. I see really only a couple issues with it so far. I haven't really dug into it, but very good condition. As far as I can tell at this point, it just needs to be recapped. And I'm also going to get rid of the 2-prong cord, put a 3-prong cord in there, and then of course get rid of the death cap. And that leaves an extra switch here for the polarity switch. So I talked to the owner, and what he would like me to do with that is install a half-power switch, a pentode triode switch. So I'll be doing that as well. And I'm also going to be performing a couple of safety upgrades and just reliability upgrades. A couple things just to prevent the worst case scenario where a tube fails and it burns out the transformer, something like that. So let's take a look inside. So right away we can see this amp is all original, and I'll do my best to hold the camera steady here. No one's done any work inside of this amplifier. These are all the original capacitors and resistors, except for, and I don't know if we'll even be able to see this. Let's see if I can get up closer here. Well, no, you'll just have to take my word for it. Someone installed a couple, well, maybe you can just see that resistor there. The power tubes have 1.5K grid stopper resistors installed. And aside from that, I can't find anything in this that is not original. It's really in beautiful shape. Initially I thought that maybe the transformer had been replaced because the wires are a different style. They're not the cloth covered wire like everything else in this amplifier, but as I started to look into it, apparently those amplifiers did come with these this type of wire. So that appears to be the original transformer. And again, you Fender historians, if any of you watch this stuff, you could probably tell me a lot better you know, the history of this amp when it was made, whether that transformer is in fact original, but as far as I can tell, it is. One of the things we'll be doing is replacing this bias supply capacitor, and that may or may not be in good shape still, but thing is, if a bias supply capacitor fails, that can absolutely destroy an amplifier. So I'm going to be replacing that with a metal film capacitor, actually a DC motor capacitor. Looking at the other side of the amplifier now, I'll try to get you a good close-up shot of that date code on the output transformer. I'm sorry, on the power transformer. And then, hopefully you can see this one on the output transformer. And the choke. So somebody who knows more about these vintage Fenders, chime in, let me know if those are all original. As far as I can tell, they are. But this is what we came here primarily to service. These filter capacitors are all original, and they are no doubt in rough shape. They're not meant to last this long. So I misspoke about that bias supply capacitor. I remembered that I couldn't use a DC motor capacitor because it needs to be axial leaded. So I ended up buying this Solon fast cap instead, which is tremendous overkill. This is a 250 volt capacitor, but that was the only thing that I could find from that supplier that would be a high enough capacitance to work as a bias supply capacitor. And you know, these are obviously meant for audio applications, but I think for a bias supply capacitor it'll work just fine. It's a little bit bulky, so hopefully it'll fit in there without any issues. I'm not even aiming at this thing, am I? Hey, here we go. See it? Anyway, F&T capacitors for the power supply, and some Sprague Atom cathode bypass capacitors. Normally I wouldn't bother with all the, you know, something like this I think is just unnecessary. I use much less expensive capacitors in my builds that are actually very good quality. I would say just as good as those, but a lot less money because they don't say Sprague on them. But the reason that I decided to go with something like this, the high dollar Sprague Atom cathode bypass caps, is because it's a stinking vintage Fender, man. I mean, you gotta be respectful of what it is. And so I didn't want to put something in there that somebody else down the road would look at and think, oh my gosh, why did they put this capacitor in such a nice amp? And, you know, obviously there is a certain level of cork sniffery that happens in the vintage amp world, so with that in mind I decided to go with a more expensive amplifier so that nobody would look inside this thing and wonder who the heck touched this amp. Along those same lines, and actually this I think is a little bit more of a legitimate argument. See if I can get better light here. I've got some of these Sozo, the blue Sozo capacitors on hand if I have to replace any of these blue molded Astron capacitors, because they are designed to be a clone of those capacitors, and though I don't think that they give you a better tone, if you're trying to preserve the tone of this amplifier, I think it's a better idea to go with those blue Sozos than just, say, Mallory 150, which is also a great sounding capacitor, but doesn't quite sound the same. So you've heard enough of the rambling, let's start melting things. The first thing I'm going to do is get rid of this two-prong cord. I don't know if the camera is really focusing well on this, but I'm going to take this out, and I'm going to leave this two-prong accessory plug in place here. You'll have to forgive my left-handedness. And while I'm at it, since I'm leaving this in here, I'm just going to clean up these, get out of my way, clean up these contacts on this plug here. That's much better. Now it looks like someone cares. Here's the other end of that death cap. See if I can grab onto this. You know what? I'm gonna use my other tool here. And this might take a little while to melt because there's a lot of metal sinking this heat. But you know, I've never watched anyone remove one of these before. I'm wondering if it's better just to clip this. This is going to take a long time. Oh, nope, there it goes. Finally let go for me. So now I've just got this ugly blob of solder on the back side. I tried to get rid of some of this solder here, but I think short of using a torch, just because there's so much metal sinking the heat away, there's really no way that I'm going to get this solder off of here. So it's kind of ugly, but not much that I can do about it. And there's your death cap. I am kind of curious how well this held up. Let's see what we got here. 46.1 nanofarads, so this is actually right on spec. So in the place of this polarity switch, I'll have this pentode triode switch, which is, this is a Carling, so very good quality. And it happens to be, well, as you can see, this is a long bat. The original was a short bat. So it'll stick out a little bit more. But, more importantly, this is the same size, and it's also keyed the same. So once I get this nut out of the way, let's see where it was at about there. Ah, come on. So yeah, great fit. There we go. I was going to install this cord, but it just occurred to me this is 16 gauge. The old cord is 18 gauge. This strain relief wouldn't even fit over this, so I'll have to order a new cord before I can install that. Now this is odd. This makes me wonder if maybe someone has been in here before, because this lead is soldered on. It looks like somebody clipped off the original capacitor and soldered the lead onto there. That doesn't seem to want to come out, so maybe there's a reason they did it that way. Although that one's not clipped. That's the original lead. Well, I don't know. This is also interesting. This is a 16 microfarad capacitor, and the schematic that I have calls for, I think, an 8 microfarad capacitor. Just gobs of solder on these things, my goodness. Now for some reason these two capacitors don't want to pull out, so they must have, these leads must be going somewhere. Oh, maybe they're going over, I bet that's where. I bet they're going over these balancing resistors. And for that matter, maybe that's what these wires are. Maybe I'm going to find out that these resistors don't come out very, very easily. Yep, there we go. Those are not coming out. Well, that's interesting. So I learned a little bit about how Fender put these things together. They actually used, looks like, and we'll find out for sure here in a minute, but it looks like they used the leads from these resistors to connect the circuit, come through here to the capacitors. So I just finished up cleaning up all these eyelets, got as much solder out of them as I could. You know, I probably didn't have to, and one of the things that I see a lot of people doing is they'll just, they'll reflow the solder and then push the leads for the new capacitors through. Problem with that is that you end up with this big glob of solder on the underside, which is what I saw. And this is, see if I can hold that in a spot where you can actually see it. See that nice blob of solder there? That was rolling down this solder wick when I was cleaning off one of these eyelets. I think it was this one here. That's all from that. I probably went through a couple of feet at least of solder wick. I wish I had a solder sucker. You know, I've got a handheld oscilloscope with a built-in signal generator, but I don't have a solder sucker. What is wrong with me? Anyway, that's about it for today. It's not the end of this video, but that's it for me today. I'm kind of running out of time here. I don't know how amp techs make a living. There's no way that I could charge an hourly rate for something like this, not if I wanted to do a good job. Maybe they're just incredibly fast, or I'm just incredibly slow, but this is, you know, it's pretty time consuming if you really want to get this right. And again, being respectful to what this amp really is, I want to make sure that I'm doing a good job with this. So, one of the things that's stopping me from doing anything else today, in addition to just time constraints, is this capacitor right here. This is a 27K, I'm sorry, capacitor, resistor. This is a 27K resistor, and I don't have any of those in stock, so I'm going to have to order those. And as I mentioned earlier, I'm going to have to order a new power cord for this, an 18 gauge power cord. So I will have to wait for a couple of parts to come in before I can do a whole lot more with this. So in case you're wondering why I'm going to be replacing those power supply dropping resistors, most of them measured okay. They were all off spec, but not by a ton. The worst ones were actually the balancing resistors, and even those really weren't terrible. However, there's no benefit to keeping them in there. The carbon comp resistors do not, and you know, obviously there's a lot of debate about whether carbon comp resistors actually benefit the tone of an amplifier. And my stance on that is that in certain locations they can, in other locations they just add noise. The power supply is one of those places where I don't think anybody's going to tell you that it's actually going to benefit the tone of the amplifier to have carbon comp resistors in the power supply. All they're doing is dropping the voltage. There's no magic going on in there. So anyway, those are coming out. Those are going to be replaced by some 2 watt, and I don't have to use 2 watt, but this is what I've got. 2 watt metal film resistors, and so those will not drift off value over time. So the capacitors that I took out were, it was interesting because the first 2 capacitors, the 70 microfarad capacitors, were so far off. I mean, they were measuring, I think one of them was measuring like 19 nanofarads, the other one was measuring like 6 or 7 nanofarads. So basically just completely dead. And the ones in the preamp, the 22 microfarads and the 16 microfarad, those were actually pretty darn close. The 16 had drifted up to 20, the others had drifted up to 21, 22, still pretty close. No, I take that back, one of them was up to 28, but aside from that, you know, they were still working, still doing their job, but these first 2 were just totally dead. So anyway, that is it for my day. I'll come back next weekend. This video is not over. We'll keep going. Okay, day 2 of this project. I've been here in the shop for a little while already. I went over a bunch of stuff before I started recording. One of the things that I wanted to do was go through the amplifier and just check all of the component values, make sure that things haven't drifted so far off that they're going to need to be replaced. And I was actually surprised at how well things have retained their values over the years. There were a few that are going to need to be replaced, but nothing major. It also occurred to me that this the capacitor that I had ordered for the bias supply is the totally wrong value, so I'm going to have to get another one. Those are kind of, it might be tough to find the right one, so I may end up just going with a good F&T capacitor for the bias supply. But I definitely can't use the one that I ordered. So I've already taken out all of the cathode bypass capacitors. I knew ahead of time that those were going to have to be replaced. I was actually surprised to see that they had only drifted up to about 35 microfarads. That's pretty surprising given the age of the amplifier. I don't know a whole lot about these, or the whale, I think, yeah. So these whale capacitors. I looked them up and I couldn't find any information on them, but you know, obviously they're electrolytics, but they must be very good electrolytics. So just in case that's one of those parts that you know, people like to hang on to and really doesn't need to be replaced, I'll give those back to the owner. I went through and checked all of the resistors, all of these coupling capacitors, every single one of these Astron capacitors, and these as well. They are just spot on. So that's good news. None of those have to be replaced. Of course, I'm still gonna, you know, after everything's been replaced here, I'll fire it up, and if I hear some noise, then I might have to go through and check for DC leakage. But early indications are that these are still in really good shape, and I won't have to worry about that. Also, all of these carbon comp resistors, these are all pretty predictably, as I went through, all drifted up about 10%. And that's not enough to cause any issues. So I'm going to leave those alone. There's no reason to replace any of those. These two, however, now this is interesting. The only resistors in this whole amplifier that drifted up in value were the power supply dropping capacitors. Those drifted pretty significantly. And these two. One of these drifted, and these are 220K resistors. One of them drifted up to 270K. The other one drifted up a little over 300K. So pretty significant. Those are the negative feedback resistors. So they're connected between the plate and grid of the two power tubes. So when you have a resistor that's being used close to its design limitations, it's going to drift a lot more quickly. So we expect to see that in the power supply. Now, if you think about it, because of the plate voltage, these are probably operating pretty close to their design limitations as well. If I remember correctly, these half-watt carbon comp resistors are rated for about 300 volts. So, those need to be replaced, and I'm going to do something interesting here. Part of the character of a vintage amplifier is the drift of the components. If you replace everything with the same value components that it originally had when it was built, this amplifier is going to sound just like a reissue, a hand-wired reissue would. Aside from some subtleties in the transformer and maybe different resistor types. But the reason that vintage amplifiers each have their own character is because these components drift. Now, if you've got a capacitor that drifts really high, that's going to give you a bassier sound. If you've got a capacitor that drifts low, it's going to give you a tighter, brighter sound. And in this case, these resistors, since they're the feedback resistors, since they drifted high, that means that less negative feedback was getting to the power tubes. That means that this amp was breaking up a little bit earlier, a little bit more smoothly and gradually, more like a Vox as compared to something like a JTM45 that's got a lot of negative feedback. And so that's a part of the character of this amplifier. So I want to replace those with something that's going to retain that unique character. So since one of these was measuring 270K, rather than replacing it with a 220K resistor, I'm going to replace these both with 270K carbon comp resistors. But because these are probably operating pretty close to their design specs, I'm going to bump these up to 1 watt. Because a 1 watt resistor has, not for the higher dissipation, but for the higher voltage rating. So these won't drift as quickly as these did. All of these cathode bypass capacitors also drifted, as with everything else, and they were all measuring right around 1.8K rather than 1.5K. That biases it ever so slightly cold. Even if they had drifted a lot, it really wouldn't be a concern, unless it was really excessive. The time to be concerned about that drift is if one of them drifts high and another one in the successive stage drifts low, because then you've got a cold biased stage feeding a hot biased stage, and that can cause blocking distortion. Okay, just a quick explanation of hot biasing versus cold biasing. I know not everyone watching these videos is real familiar with this topic. We start with our input waveform, and the dotted line is going right through the center of the waveform. And as it's amplified, it's still going through the center of the waveform. That's center biasing. And in center biasing, and actually I should preface this by saying that any clipping that occurs in a preamp tube is because of two things. First, the limitations of the power supply, the voltage that's being fed to this tube. You can't have an output swing that goes any further than the voltage the tube's being fed, obviously, and you can't go below where the cathode is sitting. So as it reaches those constraints, it stops amplifying, and on the top here, as it reaches the limitations of the plate, that is saturation. As it reaches the limitations of the cathode, that's cutoff. Now the difference between saturation and cutoff, there are a couple things. The main difference that you're going to hear, though, is that saturation, in other words being limited by the plate, tends to be a softer clipping than cutoff. And so driving a tube into saturation can be a really good sound. The problem is, as you drive it into saturation, the grid conducts more, and you get blocking distortion. So, and this is especially problematic if you have a lot of low-end signal there. So in a lot of amplifiers that have real big coupling capacitors and big cathode bypass capacitors, you can run into blocking distortion a lot more easily than something like a Marshall amplifier that's using a 0.68 microfarad cathode bypass capacitor and a 0.022 coupling capacitor. It's much more problematic in Fenders that use 0.1 maybe coupling capacitors with a 25 microfarad cathode bypass capacitor. So in this example, this red line is the center of the waveform. This black line is where center bias would be. So by cold biasing this stage, we've moved everything downward a little bit, and that causes it to clip on the low side before it clips on the high side. So the opposite happens here if we hot bias the stage. We move everything upward a little bit, and that causes it to clip in saturation before cutoff. Now that on its own is not necessarily a bad thing, but it can contribute more to blocking distortion. So normally we would stay away from hot biasing a preamp stage if we know that that stage is going to really clip a lot. So the reason that, as I mentioned before, it could be an issue if one stage is if one stage is cold biased and then the succeeding stage is hot biased, is because we're inverting the signal at the output of each stage. So if we cold bias one stage, then right away this is going to be moved upward in the next stage. And if that stage is then hot biased on top of that, we're going to be really severely clipping in saturation before we get any clipping in cutoff. And that's the sort of thing that causes a lot of blocking distortion. Now, as for the reason why a lot of preamp tube saturation causes blocking distortion, that's not a topic I'm going to cover in this video. It would take a little too long to explain it. If you really want to understand it, buy Merlin Blenco's book. Okay, so I've gone through and replaced the cathode bypass capacitors, and I always wondered why I see other amp techs twisting these negative leads together. Now I understand. There are so many leads stuffed into the eyelets here and here. There's no way you'd be able to get both leads from these capacitors in there. The original capacitors had a single negative lead on them, so it worked. So as I did this, I cleaned up these eyelets as I did on the power supply. I'm not going to go through and do the whole amp because it's just not necessary. Now here's another reason I didn't want to reflow all of these eyelets. You can see the end of this wire is black. That's the old burnt flux that has wicked up into the end of the cloth insulator on this wire. And I didn't want that to happen in too many places because it doesn't look very nice. But You can see these eyelets have the appropriate amount of solder in them. Everything got good and wet, and the eyelet is full of solder, but it's not mounding up on top of the eyelet like, well, everything else that's factory stock. And I've put these two 270K 1 watt carbon comp resistors in here for these feedback resistors. So those are both nicely balanced again. And again, one of them had been about 270K, the other one was well up over 300K, so that was creating some imbalance in the power amplifier. And because of the higher voltage handling of these 1 watt resistors, hopefully they will stay balanced as they age. And again, we'll get the nice benefit of the decreased negative feedback around the power tubes, which will retain the character of this amplifier. Well, that's where I'm going to stop for today. I can't do a whole lot more until those parts come in, and of course I got to order a new bias supply capacitor. In the next video, I plan to finish up the power supply and hopefully get started on some safety upgrades in this amplifier. I really do want to get these videos coming more regularly again. It's just, you know, the last couple of years it's been really tough for me to get out here to the workshop. You know, it's one of those things I'm going to just have to be a little bit more intentional about it. Maybe eat dinner late a couple days a week so that I can spend some time out here. But anyway, that's it for today. Like it if you like it, comment and subscribe, and we'll see you in the next video.